we have a lot of curious minds over here, so I'm getting a lot of questions. So I think, sir, the next question comes, which says that what should be the starting point for people interested in courses like quantum mechanics and astrophysics, which aren't much prominent in India?
No. See, the point today is very different. Today you have all kinds of availability. In fact, in one of the sessions that I was doing, one parent said that he has a daughter in class 10 and she has been selected for a TCS IBM course on quantum. So these companies are actually doing this because they want their people to be there.
Yes, sir. I think two more questions, sir. Okay. So the first question says, so will we ever get quantum computers for our daily work or only the classical ones in our homes?
See, there's a very simple answer to that. Will you be doing such a complex problem in your daily work? So if your problem in your daily work is such, because then of course you will have a quantum computer. Like if your daily work involves solving various problems which would take thousands of years for a classical computer to do, you will have a quantum computer. But if your daily work is just making a spreadsheet or a simple calculation or a data set of 10,000 things, then you won't. So it is, I think we should understand, just like we talk about transport, you have let's say you can have a bicycle, you can have an auto, you can have a car, you can have a truck, you can have a Boeing aircraft, you can have a rocket which Elon Musk is making. It will depend upon the problem that you are saying, right? If Elon Musk is making a rocket to Mars, but you have to go only to Connaught Place in Delhi, then it is of no use to you, right? So that is the point. If your daily job will require that complexity, it will. But I want to I'm creating a set of resources for people to learn quantum on their own. So the previous question was, how do we go about? Today it is very possible, and you can get free time on quantum computer. So D-Wave and many others are giving you free time on quantum computer. So 1 minute of computer time you will get. But if you can use it for something useful, they will keep on extending it, because they also want people to be able to do that. So today you can work on a Google computer, you can work on an IBM computer, you can work on a D-Wave computer, all from wherever you are. And in fact, my suggestion to schools is that if they have enough students who are interested, or a group of schools who have enough, they should create a quantum computing club and let people explore this thing. Because today is only issue of learning. Resources are unlimited at various levels, and when you have a group which is learning, they can help each other figure out. So peer-to-peer learning will be much more effective than instructor-led. You have one big professor who will come and tell you that one kind of thing, but if people want to learn together, that will become a very important thing in terms of a learning community. Yes,
so yes, sir. The last question is, what happens?
No, you can continue. I'm very happy that there are so many questions.
Okay.
So I feel somewhat fulfilled that I am doing something which is of interest to them.
Yeah, so they're sending me questions, like as in when I'm probably posing a question to you, I'm getting another question.
Good, that's all right. So as long as they ask questions, you can.
Right, sir. So the next question says, what happens in the gray zone between solid and liquid, and what is matter made of?
No. So matter is eventually made of elementary particles. So that is the thing. Now, when we talk about solid or liquid, it's a question of what is in fact, solid, liquid, gas, etc., etc. This is a question that a large number of elementary atoms or molecules, or typically molecules, get together. In a solid, they put together in a fixed place. So the arrangement is such that they are in a fixed thing, which is called a lattice structure of the solid, and typically it is a repetitive cell, and like various things. Liquid is when they are not within that, and they are somewhat not at fixed positions on a lattice structure, and there is a radial distribution function that when you take any particular molecule or atom or whatever, you can say at so much distance, so many particles would be there, and so on and so forth. Gases, when they're much more liberated, continuously going all over, and have no tendency, so this is different kind of properties. Then you can have special things like superfluidity, where it's flows into a certain laminar flow, etc., etc. So various combinations. It's basically particles and the distances between them and the forces that are acting, which will give rise to different states of matter. You know, there's also something called plasma, where it is only ions that are being talked about. Yeah.
Yes, sir. So the next question says, can quantum mechanics explain superconductivity?
Yes, yes. That is one of the big success. The big success of quantum mechanics was in explaining superconductivity and superfluidity, and the famous theory is called Bardeen-Cooper-Schrieffer theory, BCS theory. And Bardeen is a very interesting person. He won the Nobel Prize for making the transistor with Shockley, and with Cooper and Schrieffer, he got the Nobel Prize for this theory of superconductivity. And superconductivity means that there is lossless flow of electricity. And quantum computers use superconducting magnets and superconducting temperatures for this thing.
Yes, sir. So the next question is, isn't it possible that this technology could lead to one-sided wars?
Yeah. See, war issue is something you cannot say. See, when the First World War started, did anybody know that war is coming? When the Pearl Harbor happened, did anybody think it would lead to a world war? So therefore, war can come on anything. War is human behavior. They can trigger out of anything. And there were crusades. They were all religious wars. The number of crusades, they were all religious wars. So the war can be on anything. And people suspect that people who have the latest technologies are better equipped for warfare. Just like when one side had horses and the other side only had elephants and camels, there was a difference. When one side had gunpowder, it was a different thing. One side had a nuclear bomb, it was a different thing. And today I told you that AI alone is capable of lots of very effective warfare. In fact, there is no need for, and somebody mentioned biological warfare. So I often said the chief of defense staff tomorrow will be a virologist. It doesn't have to be a army or navy air force person, because people can release these viruses and so on and so forth.
Yes, sir. Okay. So another question says, if quantum technology is much more useful, then why are we taught classical mechanics?
Okay, see, point is very simple. You are taught classical mechanics because people believe that if they learn something in their MSc, then the other person has also to reach their MSc before he will be taught that. This is true of many things. Many things we push to be taught earlier. People have that chronological thing. The second thing is, this thing happens so fast. The usefulness of quantum technologies has come only in the last 5 years or so. So it has not reached people in enough numbers to understand. But as I told you in the beginning, or somewhere, that Nirmala Sitharaman did allocate 8,000 crores for quantum technologies. 8,000 crores is nothing. But the fact of the matter is they agreed that just like in the 1960s, they created something called IITs because they thought they are important. They are acknowledging, and Indian Institute of Science has already got a center for quantum. And I said Roorkee University in their engineering courses have created one semester course on quantum with collaboration of Microsoft. So the point is that it takes time for people to accept and adopt things. But, yeah.
Yes, sir. So this is all. So we have a lot of teachers who have shared a few messages. So I would like to read out one of them. It says, thanks a lot, sir, for this session. It was extremely stimulating and has definitely motivated our students to explore the quantum mechanics. I am sure that our students will start thinking about becoming quantum ready, which in the real sense is becoming future ready. The future definitely belongs to self-learners, and the ones taking leaps in the self-learning will be leaders. Thank you so much, sir, from the Ramjas family.
Okay, thank you. All the best. Now, I'm happy that this has turned out to be something which people could engage with, because I was worried it might all go over the heads of people and they may have no interest and so on and so forth. Because I don't think there are too many sessions on quantum thing for the children, school children. I haven't heard of any other.
Right, sir. You won't believe I've been getting so many questions that probably I don't know if I've missed on a few, but I believe we have a very curious audience here, sir.
Yes. So if there are a couple of questions you want to take up in a hurry, I'm quite happy to deal with them.
Okay,
But
okay. I think
otherwise,
I've received one question, sir. This child is messaging me again and again. Probably this question says how gravity works.
oh, see, there are that is the unsolved problem. So, so that is the unsolved problem. And Einstein had the general theory of relativity where he says it's got to do with curvature of space and time. It is not a separate form. The curvatures are called geodesics, and this geodesic itself is changed by a man. It's one of the difficult things, and especially reconciling it with quantum mechanics is the challenge. So gravity separately is fine, but putting it into the framework of what is called the standard model is an unsolved problem. So he should pick it up, and he can say that later on I will become somebody like Einstein who will build upon that theory, and gravitons and gravitational waves and so on and so forth, quantum loop gravity. The whole field is there, and it is a great field for him to explore.
Right, sir. Okay. Sir, I would really like to give a formal note of vote of thanks, sir. Sir,
Okay.
I'd like to say that thank you so much, Dr. Pant, for sharing your narrative on quantum readiness, getting to know about the latest technological developments as well as the basis, as well as the pioneers and the basis of various upcoming technologies in the field is always awe-inspiring. And when it comes from an expert like you, it becomes even more engaging and interesting. So I once again extend a hearty thanks from all the staff members and students of the Ramjas family. Thank you, sir. Thank you so much.
Thank you. Thank you.